So Neil's got a sample of sodium. Sodium is a very reactive metal. It's stored under an oil to stop air or moisture getting on it, stop it oxidizing, and stop it reacting. And you can see it's a very soft metal. So he's going to put his knife in and withdraw the lump of sodium. So there's about 2 kilos of sodium here. It's a really quite large rod. So we're going to cut a small sample of the sodium, and we're going to see if we can explore some of its chemistry.
Sodium is again a light metal, rather like lithium, and it has a melting point about 96 degrees.
So the sodium is a very, very shiny metal, and as you see, as Neil cuts some off, you can see the really quite nice shiny material. Really quite beautiful. Reacts very, very quickly with air and also with water. You form the oxide layer, which is the white, or the hydroxide is the white crust on the outside.
And many of you will know that if you drop sodium into water, it reacts almost explosively.
So we're gonna go outside now to do some bigger reactions with some of the alkali metals. So this is a dog bowl, which is stoneware. It's very hard, not likely to break unless I drop it on my toes. This is sodium, the metal that we cut a minute ago, and you can see there's quite a substantial amount of the sodium, and we're going to pop it into the water and see what we can do with the reaction. Okay, so here we have a bowl full of water, and maybe, a gram of sodium? So let's see what happens, see what this reaction's like. So it's reacting really, really quite quickly and really violently with the water. And you can see it's fizzing around as it's generating lots and lots of hydrogen gas. And you see now the heat from the reaction is burning away all of that hydrogen which is generating. And you can see the orange sodium flame. That was good.
That's a good chunk of molten sodium's come out of there, mate.
So, let's burn that. Oh, it's on your camera. Oh, it is too.
Sodium chloride is transparent to infrared light, and so here we've got a sheet of sodium chloride that has been stuck onto a glass vessel so that you can have infrared light going through it. Now this is a broken one, which my students have broken.
Does that bit... Have you got... And we need a needle, Neil, or a pair of tweezers.
So you can see here that these windows have been broken, but you can see an interesting aspect of sodium chloride, that when it breaks it forms cracks that form at right angles.
Why is that?
This is related to the structure of the atoms inside the crystal, which are arranged in a sort of cubic arrangement. I've also got quite a nice crystal of sodium chloride over here, which I don't know if you can see. It's been turned into a table lamp, and if you switch it on, it lights up. So this is just a mass of natural sodium chloride from under the ground somewhere, probably in Cheshire or somewhere else like this where they have large underground saltnite deposits.
Okay, so we got a lump of sodium, and you can see it's really nice and shiny. Okay, so we're going to pop that into that big bucket of water, see what the chemical reaction is. Okay, so here we go. So you can see the orange sodium spectrum as the sodium is getting excited as the hydrogen's burning, all that heat. Whoa, exciting! That's brilliant.
That's much better, wasn't it?
So, sodium and water. Excellent reaction. That's great.
I like sodium because its symbol Na was the nickname that my mother, whose name was Ina, used to use when she was a child. She was known as Na. So whenever I see sodium in a formula, I sort of feel a sort of warm, motherly feeling from this.